Welcome to this presentation on diffusion. In this lesson, we will explore diffusion in terms of the kinetic particle theory. We will also look at how the relative molecular mass of gases affects the rate of diffusion. Diffusion is the movement of particles from an area of high concentration to an area of low concentration. This process happens naturally, without any external force. Note, in exams, always remember to use the words high concentration and low concentration when defining diffusion. Examples of diffusion can be seen all around us. When someone sprays perfume in one corner of a room, the smell spreads as particles move through the air. Another example is sugar dissolving in tea. The sugar molecules spread from a high concentration at the bottom to the rest of the cup. When defining diffusion, giving real-life examples of diffusion makes your answers stronger. Diffusion can be explained using the kinetic particle theory. Particles are always moving. This random motion causes them to spread out. They continue moving until they are evenly distributed. Exam tip: mention random movement of particles in your explanation because it shows clear understanding. The rate of diffusion also depends on the relative molecular mass of the gas. Gases with lower molecular mass, which means they are lighter, diffuse faster. Gases with higher molecular mass, which means they are heavier, diffuse slower. Let's look at an example to compare the rate of diffusion of some gases. To determine which gas diffuses faster, we must calculate their relative molecular masses. Let's work with these four gases: hydrogen sulfide, sulfur dioxide, ammonia, and methane. For hydrogen sulfide, H is 1 times 2 plus sulfur, which is 32, giving a total of 34. For sulfur dioxide, sulfur is 32 plus oxygen, which is 16 times 2, giving a total of 64. For ammonia, nitrogen is 14 plus hydrogen, which is 1 times 3, giving a total of 17. For methane, carbon is 12 plus hydrogen, which is 1 times 4, giving a total of 16. Lighter gases diffuse faster than heavier ones. Methane with mass 16 and ammonia with mass 17 diffuse the fastest. Hydrogen sulfide with mass 34 is slower, and sulfur dioxide with mass 64 is the slowest. So, the order is methane, ammonia, hydrogen sulfide, then sulfur dioxide. Exam tip: always show the step-by-step breakdown when calculating relative molecular mass. This gets you method marks. Let's take a look at this IGCSE exam past questions. Bromine is a red-brown liquid. A drop of liquid bromine is placed in a gas jar. After 20 minutes, the red-brown color has spread throughout the gas jar. You can pause the video and give it a try. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Please write the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with Acestudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.